All right, so what we're looking at now is using algebraic properties to rearrange a formula to solve for a variable. So this is something that you would have done in previous years, but it was something you hated. You even hate it when it's in science because when you're rearranging a formula, you're usually rearranging a whole bunch of variables. So sometimes there's not a whole lot of numbers to work with. Now, there's two different types that we'll look at, uh, but I'll focus mainly on the one that will give you more difficulty. So sometimes the formula that we need to use is not set up for the variable we need to solve for. So if you think back to our primitive formula that we've had, what happens if I don't give you, I give you the perimeter, but I don't give you the width? So you would substitute in and you'd have to keep rearranging with the numbers. Well, I could do it that way, and that's the one way, substituting the information first and then solve. Now, when you would use that would be if the numbers are simple and if rearranging the formula is difficult. So in other words, if it's easy to rearrange the formula, it makes sense to do it. And if the numbers are simple. But often the formulas we're looking at are not really simple. And what we have to do first is to isolate the variable. So in other words, rearrange the formula first and then substitute in. Now, the times you would do that would be if you had to calculate something many, many times. So even if I think of the perimeter formula, if I had to calculate the length of many different questions, but I knew the width and the perimeter, it would make sense to rearrange the equation. Okay, so we're going to look at the type 2 question the most. We have one example, and then the next little video will have the second one. So the first one is the velocity of an object thrown upwards in the air can be modeled with the equation v equals negative 9.8t plus u. Okay, now we have to figure out what all those letters are, where v is the upward velocity in meters per second at time t in seconds, and u is the initial upward velocity in meters per second. Okay, well, that's fine. Now, they want us to it doesn't say what they want us to do. Isn't that amazing? And you're thinking, good, I don't have to do anything. Well, actually, we are going to do something. We're actually going to solve. So you have to add this to your note. Solve for t. So we're going to solve for t from our original formula. So I'm going to see if I can haul it out of there. Nope, doesn't look like it's going to come in there. So let's take our formula and we're going to rearrange it for t. So I'm starting with v equals negative 9.8t plus u. So I'm interested in this t. Okay, now you can see the t is attached to something. It's being multiplied by negative 9.8, but also I have this letter plus u. So the first thing I'm going to do is I'm going to get rid of the u from both sides. So it's adding u, so I'm going to subtract u. When I do that, I end up with v minus u equals negative 9.8t. So you can see we're getting much closer to having t by itself. So here again is what I'm after to be by itself. And so I have to this time get rid of the negative 9.8. So I already told you that we're multiplying by 9.8, so the opposite operation would be dividing. So then what happens is I'm going to have t by itself, and I'm actually going to put t on the left-hand side. Okay, so all I did is I took this, put it on the left-hand side. And on the right-hand side, I have v minus u divided by negative 9.8. Okay, so Does this formula look worse than our original formula? Yes, it does. It does. But the thing is, if I was doing a lot of calculations just for t, it would make sense to rearrange it. Now, when we're rearranging, what makes it harder, and that's why I have this hint section here, is we're actually doing the opposite of bedmas. Okay, so we're doing the opposite. So the hint, do the opposite of bedmas. Now, I hate putting that there because often students make a lot of mistakes because they didn't follow bedmas. But when we're rearranging a formula, we're actually doing the opposite. So when we're isolating it. Okay, so that's the first example. Stay tuned for the second.